I want to welcome you to today's class once again. Today is our last class on SLM 303, and we will be discussing the classification and management of Nigerian soils. Classification and management of Nigerian soils. Remember that soil classification deals with the systematic categorization of soils based on distinguishing characteristics as well as criteria that dictate choices used. So soil classification is a dynamic subject from the structure of the system itself to the definition of classes, and finally in the applicant or application in the field. So soil classification can be approached from the perspective of soil as a material and soil as a resource. So development of sustainable agricultural systems such as early farming is an attempt to reduce degradation of natural resources and to find environmentally compatible way of increasing production and promoting broad-scale development. So intensification of agriculture on land currently used for traditional farming requires a thorough knowledge of the soil as a resources and attributes of the land. So information on distribution, potential, and the constraints of major soil is needed. So that the most appropriate soil management system can be designed. In addition, knowledge on land capability and suitability is also essential to determine the best land use for sustained crop production. So this unit will review current system used to classify Nigerian soils and land capabilities. So the objective is that at the end of this unit should be able to describe the advantages of soil classification and list classes or classification systems in Nigeria, as well as discuss the hierarchy of categories in the soil taxonomic classification, and explain the topographical regions of Nigeria, classification of Nigerian soils both as a material and as a resource. Classification of Nigerian soils. Soil is the thin layer covering the entire earth surface, except for open water surface and rock outcrops. So the properties of soil are determined by environmental factors. 5 dominant factors are often considered in the development of the various soils, which include the climate, the parent materials. Parent material include the rocks and physical and chemical derivatives of same, as well as the relief or slope, and the organisms, fauna and flora, as well as the time factor. There are a large number of different soils reflecting different kinds and degrees of soil forming factors and their combinations. Of course, we have a hypothetical soil profile, which shows the organic horizons that are largely undecomposed on the surface. We have the organic horizon too that are partly mostly decomposed part. We have the mineral layer mixed with humus, usually darkened. We also have the zone of maximum allocation of clay and ions and aluminium oxide, and they are lighter in color. We have the portions of A horizon transition to B, and we have the portions of B horizon transition to A. And in that order, we have zones of maximum eluviation, clay, and oxides of iron and aluminium. We have the B transition to C, and all of that. We have the undecomposed mineral, unconsolidated mineral horizon, and we have the bedrocks. So why do we classify soil? Soil scientists have developed different systems of soil classification to group soils of similar properties in one class, allowing them to exchange information on soil found in different areas. So soil classification also helps in determining the best possible use and management of soil. So soil classification is, however, a controversial subject at both national and international level. There is lack of agreement for a common classification system because soil scientists do not agree on the characteristics for differentiating and classifying soils. And major soil classification systems in use, although many soil classification systems exist. However, two systems are widely used. They include the USDA soil taxonomy and the FAO UNESCO legend. And we have the classification of soils, which starts with examination of soil profile. Morphologically, soils are composed of a series of horizons. Soil horizons are largely layers of different appearances, thickness, as well as properties, which have arisen by the action of various soil forming processes. The horizons are normally parallel to the surface. Collectively, the horizons make up what is called a soil profile or soil pedons. So a soil profile is defined as a vertical section of the soil to expose layering. Fig 1 sketches a hypothetical soil profile having all the principal horizon with a brief description of the characteristics of each horizon. Individual soils have one or more of these horizons. Very young soils may not yet have started the soil horizonation process. Hierarchy of categories in soil taxonomy. There are 6 levels in the hierarchy, which include the order, and the order is the highest category. We have the suborder, the grade groups, subgroups, families, and series, which is the lowest in the category according to USDA 1978. The order are about 12. We have about 12 orders differentiated on cross morphological features by the presence or absence of diagnostic horizons or feature which show the dominant set of soil forming processes that have taken place. Now, the 12 orders and their major categorization may be shown in the following tables and the occurrence of the major soils in the humid and subhumid areas. Now, the suborders, it is the next level of generalization, which permits more statements to be made about a given soil. In addition to morphological characteristics, other soil properties are used to classify the soil. This suborder focuses on genetic homogeneity, like wetness or other climatic factors. There are 47 suborders within the 12 soil orders. The names of these suborders consist of 2 syllables. The first connotes the diagnostic properties, whereas the second is the formative element from the soil order name. For example, an Ustav is an artificial with an eustic moisture regime associated with subhumid climate. And the grade groups, the grade group permits more specific statement about a given soil as it connotes or as it notes the arrangement of the soil horizon. A total of 230 grade groups, 140 of which occur in the tropics, have been defined for the 47 suborders. The name of a grade group consists of the name of the suborder and a prefix suggesting diagnostic properties. For example, a plaintiff is an staff that has developed plaintight in the profile. Plaintight development is selected as the important property and so form the prefix for the grade group name. Of course, we can see the different soil orders. We have the artificials, which are soil with a clay B horizon, like changeable cations, saturated, it has saturation greater than 35% and calculated from ammonium acetate at pH 7. So we have the andisols, and the unique property of andisol is the dominance of aluminum humus complexes that result from weathering of minerals. Most andisols form in volcanic or vulcanized lactic minerals. They are rich in P retention available water as well as CEC. We have the healthy soils, which are soils with a clay B horizon and base saturation that are less than 35%. They are acidic, they are leach soils from humus area of the tropic and subtropics. We have the oxy soils. Oxy soils are strangely weathered soils, but have very little variation in texture with depth. Some strongly weathered red deep porous oxy soils contain large amount of clay size iron as well as iron oxides. You have the dark clay soils containing large amount of swelling clay minerals, smectites, as well as soil cracks widely during the dry season and becomes very sticky in the wet season. Have the molly soils, which is the primary soils formed from colluvial materials with dark surface horizon as well as the base saturation greater than 35%, dominating in exchangeable calcium. We have the inceptive soils, which are young soils with limited profile development. They are mostly formed from colluvial and alluvial materials. Soil derived from the volcanic ash are considered a special group of inceptive soil, presently classified under the Andepth suborder. We have the jelly soils, which talks about the presence of permafrost and soil features associated with freezing and thawing. Example are the irregular or broken horizons and incorporation of organic material in the lower horizon. We have the empty soils with little or no horizon development in the profile. They are mostly derived from alluvial materials. We have the arid soils, and these are soils of the arid regions. Desert soils, some are saline. You have the spodosol, soils with a bleached surface layer and an alluvial accumulation of sesquioxides and organic matter in the B horizon. These soils are mostly formed under humid condition and coniferous forest in the temperate region. Have the last one, the histosols, are soil rich in organic matter such as peat and muck. Management of Nigerian soils. A fertile soil must supply adequate nutrients, be of good physical condition, and hold enough water so that the nutrients in the soil will be available for plant uptake. In this unit, here we'll be talking briefly about the management of Nigerian soils. Maintenance of soil fertility. In maintaining soil fertility, the farmer is mainly concerned with keeping the soil at a satisfactory physical condition and maintaining the nutrient supply at a desired level. A fertile soil must be in a physical condition that is favorable, for root growth, pause, cultivation to break down the soil aggregate must be done. This is important practice. This important practice will accelerate the decomposition of organic matter, which, when present, aids in promoting porosity, granulation of soil, maintaining good soil structure, and providing good vegetative cover or mulching. Together with minerals, timely and systematic cultivation also help to maintain soil fertility. However, under annual cropping, it is not practicable to keep the soil covered throughout the whole year or to avoid soil structure destroying tillage. Nevertheless, the fertility of soil must be maintained, and this could be done effectively by crop rotation, cover cropping, green manuring, application of compost, proper land use. In soil fertility maintenance, a proper rotation program of crops can be used effectively to maintain soil fertility. The alteration of legumes and non-legumes or the use of legume in rotation helps to maintain soil fertility. This is because the residue of such crops are groundnuts and soya beans improve the nitrogen content of soil through their ability to fix nitrogen in the roots. So moreover, with the incorporation of the plant residue left on the field into the soil, improve soil aeration, soil structure, and water holding capacity of the soil. So a good rotation can also benefit by minimizing exposure of soil to the risk of erosion, reduces weed infestation of land, and checks the buildup of pests and diseases on the land. Maintaining fertility with green manure. Crop rotation is an intensive system of farming. As such, the soil nutrients get depleted and exhausted at certain stage of the land use. Soil green manure crops have to be planted to replenish the organic matter and nutrient content of soil when plowed into the soil. Growing annual legumes as green manure crops in rotation with other crops is likely to be of value where sufficient moisture is available. Moisture promotes vigorous growth of the crops and causes rapid decomposition during the period between plowing the green manure crops with the soil, as well as planting of the next crop. This means that the green manure crops should be plowed into the soil to decompose before the new crops is planted. This practice is therefore usually ineffective in drier area because of moisture limitation. Thus, under fairly good rainfall condition, it can be useful aid in soil fertility maintenance. The beneficial effect of green manure are short-lived. Consequently, they must be grown rather frequently in the rotation program to maintain crop yield at a reasonable level. Farmyard manure is unquestionably a most useful aid in maintaining soil fertility and should be used whenever it is economical and practical to do so. Farmyard manure or pen manure consists of rotten mixture of the excreta of farm animals and the straw provided for their bedding, which should be sufficient to absorb the dung and the urine. Where rotten farmyard manure is usually best applied just before planting a crop. So applying it earlier in dry season, especially if it is left partly exposed, may lead to some loss of nutrients and possibly some soluble nutrient by leaching at the beginning of the rains. We have composting, composting and the maintenance of fertility. Composting is a term used for the application of the compost heap of plant and animal remains to the soil. So the decomposition or the compost mixture could include crop residue, household refuse, weeds, and other waste vegetables material, either with a or without additional or some animal of human excreta. Compost preparation may be done in heaps or in pits, depending on the climatic condition. Heaps compost are better in wet climate and pit compost in dry areas. The compost is common in many of the alternative layers of vegetation and matters of crop residue and manure. The manure or soil, which is very high in organic matter, supply active organisms which start the decomposition process. Conclusion: soil classification deals with the systematic categorization of soil based on distinguishing characteristics as well as criteria that dictate choices in use. So topography, geological process, climatic condition, vegetation, and human interference play major roles in determination of soil types. Soil management can be defined as the process of managing the use and development in both urban and suburban settings of land resources in a sustainable way. So land resources are used for a variety of purposes, compete with one another. Therefore, it is desirable to plan and manage all uses in an integrated manner. Thank you very much for listening. Yeah, I thank you for listening. We have come to the end of our facilitation class in SLM 301, soil pedology and facilitation. So as you study this, prepare for your exam, I wish you the very best. See you some other time. Bye.